Hi everyone, lovely to be here. We all know what a shark looks like. That's a shark, right? But what does a shark really look like on the inside? And how does that affect how it swims? Sharks are made of cartilage. We have cartilage too, in our ears, our nose, our knees, but a shark's skeleton is all cartilage. And its vertebral column is especially important in how it swims and steers and springs into action. I'm a chemist, so I'm going to use a chemist's approach to dissection. If I were to strip shark cartilage for parts, or examine its chemical makeup, which is what I do, I'd find that it has mineral, collagen, and sugars. The mineral, hydroxyapatite, is the same thing that makes our bones and teeth hard. Collagen is a protein that comes in fibers. You might know it from our hair or skin. I'm interested in these very molecules that make up shark cartilage. How are they arranged? How do they interact with each other? And how exactly do they make a difference in how well sharks swim? I explore these ideas with powerful microscopes. I get to use lasers, electrons, x-rays, all sorts of cool stuff. I can collect x-rays at several different angles, like you would with a CT scanner at a doctor's office. Except with nano-CT, we use a big instrument, we go big, to look at very tiny details, like how the mineral and collagen interact with each other. Cartilage is pretty flexible. To find out just how flexible shark cartilage is, I poke it with a tiny probe, and I look at it to see how the structure deforms as a result of this change. I can also cut the cartilage into very thin slices, thinner than 1/1000th of a hair's breadth, and then I send electrons flying through them. And how these electrons behave give me an idea about how the atoms are arranged within these fibrils. I want to compare these details between different sharks. For instance, our black tip over here, and also the fastest shark, the mako. What we've found so far is that the mako's non-mineralized portion in its vertebrae is more ordered and also deforms more, which we think has implications in why it's such a good swimmer. Sharks have been around for hundreds of millions of years. They know a thing or two about being flexible. We can learn from them and their expert swimming prowess to apply solutions that are bio-inspired for problems that we have. For instance, we can use what we know in tissue engineering treatments for bone and joint diseases like osteoarthritis. We can also use what we know to make strong and flexible materials that are multi-composite materials for applications in, say, marine robots. With every fiber of shark cartilage that we look at, we learn so much about what makes them powerful swimmers, and we're all the better for it. Thank you so much.